In this video, we're going to talk about angles. So let's define what an angle is. An angle is the union of two rays that share a common endpoint. Remember that when we have a ray, so let's suppose that this is a ray, this little point right here where it starts is called the endpoint. So since it says that they share a common endpoint, I can draw another ray whatever I want. Okay, let's do it here. But starting from the same endpoint. Okay, if this is the case, then you have an angle. You can name these angles using letters, like let's call this A, B, C, and then this will be angle ABC. Always with the common endpoint or the vertex. This is also known as the vertex in the middle. We can put a number to this aperture, 1. So this will be also angle 1. And when there is no confusion, we can call it whatever the name that we put to the vertex. So if the name of the vertex is B, then this can also be called angle B. Okay, so this is how you name an angle and what an angle is. We have a postulate, our first postulate when talking about angles is the next one. The measure of an angle is a unique positive number. This means that if I have an angle, let's suppose that we have this angle in between these two rays. Okay, I can use, and this is also called the protractor postulate. I can use the protractor, right, and measure this aperture right here, and assign up a positive number, counting the degrees on that protractor. If I put a protractor here, I will probably count it and we'll get like around 100 degrees. So this could be 100 degrees. And this is a positive unique number. Positive unique number for this aperture, for this angle. Okay, we have another postulate. This is really important because it says if a point D lies in the interior of an angle ABC. So let's suppose that we have an angle ABC. So we have this angle. Okay, so this is A, this is B, this is C. And maybe we have point D around here. Okay, lies in the exterior of an angle. Then the measurement, and I can draw a line here. And now I have two angles, right? Two angles. I have two angles that's being formed. The measurement of angle ABD, let's call it 1. And the measurement of DBC, let's call it 2. So the measurement of angle 1 plus the measurement of angle 2 will be equal to the measurement of the whole angle. Like that means ABC, angle ABC, right? So if I add this angle with this angle, obviously I will get the whole thing. Okay, this is a really important result. This is actually called the angle addition postulate, and it's pretty similar to the one that we learned about segments. And if you remember, when we had segments using betweenness of points A, B, C, we knew that adding AB plus BC will give us the whole thing. AB plus BC will give us AC, right? This was a very useful result, and it's basically the same thing for angles. An angle or angles can be classified. When we have angles like this, right? Let's call this 1. And the measurement of angle 1, it's in between 0 and 90 degrees. We call this an acute angle. Okay? When we have two rays like this, and let's suppose that this is angle 2, and the measurement of angle 2, it's equal to 90 degrees, we call it a right angle. Okay? When we have, I suppose that we have this, angle 3. The measurement of angle 3, it's more than 90, but less than 180, then this is called an obtuse angle, right? So if it's greater than 90 degrees, but less than 180, then it's called an obtuse angle. If we have basically two opposite rays like this angle 4, and the measurement of angle 4 it's equal to 180 degrees, we call it a straight angle. Straight angle. Also, sometimes people call it the flat angle. It's more common that we call it straight. Okay, just so you know how to call it. Let's do an example. Let's suppose that we have the measurement of an angle, the measurement of angle ABD. ABD. It's equal to 27 degrees. And the measurement of angle DBC, it's equal to 42 degrees. Okay, what would be the measurement? Measurement of angle ABC. Notice that, let me try to draw this angle ABD. So I have this ray, right? A, B is in the vertex, and D here, all right? This is 27 degrees, right? DBC means that we have another point here, and this is 42 degrees. What will be the angle ABC? So basically what it's asking me is what will be the measurement of this angle right here that I just draw with green. Okay, obviously by the angle addition postulate, I know that I can add these two angles and then I will have the whole thing. So 27 degrees plus 42 degrees will be equal to 69 degrees. So the measurement of angle ABC will be the addition of those two, that is 69 degrees. All right, so that's how we know. Now we can have harder problems. Let's suppose that we have that the measurement of angle ABD is equal to X. And the measurement of angle DBC is equal to 2X minus 3. And the same question, what will be the measurement of angle ABC? We know, and let me try to have a drawing here. We know that this is A, B, D, and this is DBC, right? So this is telling me that it's 2X minus 3. And this measurement of angle ABD is telling me that all this is X. So the whole thing, the whole angle, all this angle, the complete angle, this, right? Let me draw it here. Is going to be the addition of these two. So X plus 2X will be 3X and minus 3. So just like that, the measurement of angle ABC, it's equal to 3X minus 3, right? I don't know the values, I don't know anything else, but I know that that expression represents the measurement of that angle. Another really useful concept is adjacent angles. Adjacent angles. Two angles are adjacent if they share a common vertex, if they have a common vertex and a common side in between them. So adjacent angles needs to have a common vertex, right? And a common side. So this side right here, it's common to both angles. This side, it's common to both angles, to this angle and to this angle. Okay, so if we call it 1 and 2, angle 1 and angle 2 are adjacent. Again, why? Because they share a vertex and they share a common side. Okay. What about this two? What if I have this? Let's call this angle 1. Let's call this angle 2. Let's call this angle 3. It's angle 1 and angle 3. And angle 3 are angle 1 and angle 3 adjacent. Obviously, they share a common vertex. They share in this vertex. But by definition, we just said that they need to share a common side. There's no common side in between these two angles 1 and 3. So they are not adjacent. Right? Just that simple. Another useful definition that we're going to use a lot is congruent angles. Congruent angles are angles that have the same measurement. Okay, so if I have an angle like this, let's suppose that I have that angle, let's call it 1, and I have an angle like this, let's call it 2. Okay, if they have the same measurement, they are congruent. So if the measurement of angle 1 is equal to the measurement of angle 2, then angle 1 is congruent, and this is the symbol that we're going to use with angle 2. Okay, pretty useful result. Let's do a problem with this. I think this is sample number 2. Actually, let's erase all this. All right, so let's suppose that we know that angle 1 is congruent with angle 2. Okay, we know that the measurement of angle 1 is represented by 2x plus 15. And the measurement of angle 2 is represented by 3x minus 2. Okay, find x. The good thing about this type of problem is that clearly we have this piece of information that's really important. Angle 1 is congruent with angle 2. So what this is saying is that the measurement of angle 1 is equal to the measurement of angle 2. But I know that the measurement of angle 1 is this, and the measurement of angle 2 is that. So I can replace or substitute in this equation. So n1, that is 2x plus 15, is going to be equal to the measurement of angle 2, that I know that is this, so 3x minus 2. And I just need to solve this equation. I can subtract minus 2 on both sides. This is gone. 3x minus 2x is x. And to get rid of this negative 2, I can add 2 on both sides, right? So this is gone. 15 plus 2 is 17. So I know that x is 17, and that's it. What if I wanted to know the measurement of the angle? So the measurement of angle 1 will be equal to 2 times x, 2 times 17, plus 15. This is 34. 34 plus 15 is going to be 49 degrees. That will be the angle 1. Another interesting result is the bisector of an angle. Okay. The bisector of an angle is a ray or a line segment or a line that separates the given angle. So if I have this angle, we suppose that we have this angle, and we have a ray that separates them. So, and this ray separates these two angles into two congruent angles. So a bisector of an angle is going to be a ray, a line segment, or a line that divides the angle into two equal parts. So where angle 1 is congruent with angle 2. That's it. All right, that's the result of bisector of an angle. Other terms that we're going to use a lot is the complement of an angle. So two angles are complementary if the sum of their measurements is 90 degrees. So what this is saying is, if I have an angle that is 30 degrees and I add it to another angle of 60 degrees, this is 90 degrees. These two angles are complementary. All right. What about if we have, I don't know, 70 degrees, angle 1. What if we have that the measurement of angle 1 is 70 degrees and the measurement of angle 2 it's 110 degrees? If we add them, measurement of angle 1 plus measurement of angle 2, it's equal to 70 degrees plus 110 degrees, and they will give us 180 degrees. So if we add two angles and the measurement is 180, then we said that the two angles, angle 1 and 2, are supplementary. So quick recap. If the sum of the measurements of two angles is 180, they are supplementary. If the sum of the measurement of two angles is 90 degrees, they are complementary. Okay? In another video, we're going to solve harder problems related to this. See you in the next video.